Hello, this is Pete Cacciopi. I'm Chief Scientist at Analytics, and I'd like to give you a talk today about prescriptive analytics with Python. To begin, let's talk about the Python language itself and why we're promoting Python as the best language for prescriptive analytics and for analytics in general. First and foremost, Python is a scripting language, so that means it's interactive, right? Interactive languages are generally easier to learn. You can conduct little experiments. You can learn the way people naturally learn with rapid feedback loops. But with Python, you get to combine that with a massive massive set of online resources to support learning. So there are many free or low-cost Python courses on the internet, and there's also a great many websites that provide answers to common Python questions. So these two things, interactivity and massive online support, are unique to are areas in which Python is indisputably the leader, right? So if you look at scripting languages, if you look at the adoption rate of scripting languages, Python is the leader far and above, right? The only languages that are used more than Python are languages that are not scripting languages. Languages that are used more than Python are languages like Java or C, and those are fundamentally more complex languages, and they're not really as appropriate for sort of the interactive programming work that data scientists do as part of their job. Of course, as Python's sort of in a virtuous cycle, right? As more data scientists use Python, the quality of the tools and the quality of the libraries available for Python continues to improve. So Python has a rich set of libraries for machine learning and for other statistical work. It also has productivity tools like IPython, which is an interactive Python interpreter. And it has Jupyter Notebooks are well supported with Python. Jupyter Notebooks allows you to create, allows you to document your interactive programming sessions with text and incorporate graphics. Again, this is an area where Python excels. It sort of stands head and shoulders above other choices. Python now, it's very easy to find mixed integer programming engines that have Python APIs that support algebraic modeling. So when you're building your constraints in Python, you can build them using the same sort of natural mathematical formulations that you would use in even these dedicated one-off languages like AMPL or OPAL. So it's very similar to build constraints now with Python, regardless of your choice of mixed integer programming engine. Python makes it very easy in order to modularize your work. So in other words, it makes it very easy to turn a body of Python code into a library with sort of obvious entry points and incorporated documentation and incorporated testing, right? So this, it's easier. So Python is wonderful for exploratory programming, right? It's wonderful for situations where somebody dumps a pile of data on you and you just want to play around with the data, see what sort of results you can find. But it's also good for sort of the other end of the spectrum where you want to produce code that's professional, and to that end, you want to produce code that's modular and easy to understand and easy to share. And Python excels at both of those tasks. So let's talk a little bit about why prescriptive analytics is so hard. Some of the specific challenges of prescriptive analytics. One of my favorite blogs, I believe the title is optimization is IT's best kept secret, right? And that's an unfortunate state of affairs. And we're Analytics and this blog that I'm referring to, it's Jean-Francois Peugeot's blog at IBM, share the common goal that optimization should be less of a well kept secret, right? So, well, let's talk about why JFP would say that. So the task of prescriptive analytics, I would define it as mapping business problems, creating numerical solvers that map business problems to core mathematical engines. And the focus here is using mixed integer programming as the core engine that you map onto. But of course, constraint programming and other types of heuristic engines are also well supported with Python. Now, one area that I think makes prescriptive analytics so challenging is that it's brittle with respect to its inputs, right? So in other words, machine learning, if you go through a machine learning book, you will find many examples of machine learning algorithms where they talk about, okay, this is a technique for which we run this technique on a single table. that has many fields and many rows, and we need to flag one field as the dependent variable, and then all the other fields are independent variables. And that's about as complicated as the schemas get. With mixed integer programming or prescriptive analytics, it tends to go sort of the other extreme, right? So mixed integer programming engines are built around a specific input schema that has and they tend to involve a fairly complicated set of rules. And those rules tend to be poorly documented and, loosely enforced, right? So for example, if you look through the Cplex examples or the Gurobi examples, they present, a variety of sample engines, but those engines don't validate their input data in any way. So I'm not knocking on them. That's not their job to show you how to validate the input data. But it is a challenge, right? And you ignore that challenge at your peril. If you build engines that don't validate their input data, then you won't be well prepared for dirty data. And dirty data is simply just a reality of life, right? So for whatever reasons, people miscommunicate about what the data is supposed to look like. Flaws at the data entry level. Who knows? There's a long list of reasons for where dirty data comes from, but you shouldn't pretend that it doesn't exist, right? So you really can't build these engines ignoring the reality that you may encounter problematic data. That's not a good process. That's not a good development practice. Although I agree that it is a development practice that's often ignored or sort of glossed over, right? So some organizations ignore it. Other organizations will validate their input data, perhaps using SQL, maybe write access databases whose job it is to have queries that look for problems in the input data. But it would be nice to have that work be more automated and more straightforward. So the underlying common theme here is that in order to do prescriptive analytics, you have to bring a variety of skills together, right? So the skills that we're looking at are you need to be a mathematician, you have to have mathematical knowledge and insight. You also need to have a certain amount you need to be an expert in a certain business area, and you also need to obey certain software engineering practices. So those three disciplines all come together, right? Business analysts, mathematics, and software engineering all are in play when you're building prescriptive analytical engines. And I think this is part of the reason why it's such a well-kept secret, because it requires these three skills all at the same time, and it's a difficult, that's a difficult hat trick of skills to bring into your organization. And what Opolytics is about is trying to facilitate the software engineering end of things, right? So we feel like, okay, organizations that already have people with business expertise, business understanding, and already have people who are, competent or better than competent mathematicians, we can facilitate the software engineering by promoting best practices with Python and by providing a cloud platform. So this brings us to this a library that we've put on PyPy. It's an open source library that anyone can download and install called TICDAT. And essentially the goal of TICDAT is to promote good development practices when building predictive analytical engines with Python. So specifically, we feel like we bring a lot of help in the area of validating the input data, making it easy for you to define the input data, define the schema for the input data, define the schema for the output data, and make it very easy for you to build rules that will validate the input data. In fact, really the validation steps are inside of TICDAT itself, and really all you have to do is define the types of data, the basic definition of the data integrity. You have to show what you can define what type of data cells are expected for certain fields. If there's numerical fields, you give a range. If there's string fields that have a flag value, you can list the type of strings. And then when you have multiple tables, you define how the tables cross-reference each other, and you also, a very common pattern is that the tables have, data fields and key fields, right? Keys. There are some fields that identify a unique row in the data in the table, and then there's some fields that provide the actual numerical data that gets plugged into the mixed integer programming engine. And we make it easy for you to validate the data and define the data and validate the data. So that's a sort of a non-sexy step that often gets glossed over. And we promote that practice with Python through TICDAT. TICDAT also makes it very easy for you to build engines sort of in a consistent way from one project to the next, because we provide data structure templates, right? So your data, we live on the other, we complement the APIs that come with your engine. So we're not, we facilitate reading data and writing data in a standard way across all of your projects, so all of your projects will be more similar to each other. And we also facilitate file I/O in different formats. We save you the headaches of having to understand how the XLS library works, or how the CSV library works, or how the ODBC library works. All of those details are handled for you in these thin layer wrappers that live around those data I/O libraries. So you don't have to read data directly yourself. You can use TICDAT to read the data. As a side benefit of that, as a side benefit of using TICDAT in order to read and write your data, we make it very easy for you to convert the data from one format to another. And in particular, we make it easy for you to convert the data into a very readable format, this .SQL format that's based around SQLite. And in such a way, you can store your data sets right alongside your code in your testing, the test suite section of your package, right? So this makes it, so the bottom line here is that we facilitate incorporating testing into your engines. And to do that, we facilitate building a library of data sets, a library of data models, right in the same package for which you define the engine itself. And of course, a bonus purpose, right? I mean, this is sort of two birds with one stone. We would love it if you were to deploy your engines with Opolytics, right? So that's the part of the business where we're trying to make money. We welcome partnerships in a variety of areas. We feel like we have the expertise to support a variety of different business problems. But again, the TICDAT library itself, there is no obligation with it. This is a free open source library that you can install from PyPy just using pip install like any other Python package. So hopefully you enjoyed this talk, and you'll follow me to these subsequent videos where I deep dive into specific code examples. So I have a diet example. This is everyone's favorite example. And of course, diet's a little bit too simple, so I also have a multi-commodity network flow example. So I look forward to seeing you there, and thank you for your time.